For centuries, Mars has pulled us in, a world that looks like a future. But it's built to kill you. But this isn't just romance. There's a scientific and strategic reason we're pushing to colonize the red planet. Mars is smaller than Earth, just over half the size, yet it offers a rare window into the solar system's early days. Its surface is ancient, a frozen archive that may still hold evidence of past habitability. And beneath the polar caps lies a reservoir of water ice, enough, if melted, to cover the planet in a shallow global ocean. Curiosity and perseverance found organic molecules on Mars. Not life, but life's ingredients. So how did they get there? In the 2030s, we plan to bring Mars home, a tiny capsule carrying ancient dust. And it may answer questions we've chased for decades. Mars has the ingredients for survival: ice, CO2, and mineral-rich soil. The rest is engineering. On Mars, survival means living off the land. ISRU pulls ice from the dirt, turns it into oxygen to breathe, and fuel to get home. Moxie proved it. Oxygen from Martian air. Small machine. Massive step for habitats, fuel, and long-term survival on Mars. Mars dirt isn't dirt. Heat it, bind it, and print it into bricks. Walls that can shield a habitat from radiation, brutal cold, and micrometeorite hits. Regolith can become the first construction material on Mars. 3D, printed into panels and bricks, it adds insulation, and a second layer of shielding where thin air can't protect you. Mars isn't just exploration. It's redundancy, another foothold, so one war, one disaster, one climate shock doesn't end the story. A backup planet for civilization itself. Mars isn't next door. The gap swings from 55 to 400 million kilometers. So we wait for the launch window, then ride a Hohmann arc for 6 to 9 months through deep space. Left, lunar dust. Right, Martian soil. Mars has thin air, steadier temps, ice, and Earth-like gravity, so it's better for a base. The moon is close and reachable in days, but harsh and airless. Mars is distant, yet offers resources, geology, and radiation shielding that make long-term settlement far more realistic. Mars isn't just a desert. Its dried river deltas, canyons, and volcanoes are a planetary memory, layer by layer. Even with weak shielding, its gravity and geology make long-term living possible. Dust devils can tower tens of meters high on Mars, lifting fine dust, reshaping dunes, and sometimes sparking static. They look small until one crosses your path. Global dust storms, like the 6-month storm in 2018, can dim the sun and challenge surface operations. But with proper engineering, these hazards remain manageable. Radiation on Mars is relentless, much higher than on Earth. That's why habitats need shielding, and the safest living space is underground. On Mars, thin air and brutal cold drive the rules. Dust moves fast, but the low pressure changes how you work, sleep, and keep machines alive. Before Mars, we rehearse on Earth. Analog habitats test the hardest part: routine, confinement, and doing everything by procedure for months. Artemis is the rehearsal for deep space, life support, navigation, and procedures far from Earth. It's how we learn to live beyond low Earth orbit. Perseverance keeps moving, meter by meter, reading the rock record of Jezero. Every track is a new clue about ancient water and what Mars used to be. Ingenuity proved flight works here, in air 100 times thinner than Earth. Every hop expands the rover's reach. Mojave drone tests, planned for 2025, are refining rotorcraft technology for future Mars missions. Future Mars habitats will be modular, pressurized cores wrapped in radiation shielding, built to expand, repair, and survive dust, cold, and long missions. Human missions to Mars are no longer a single nation's dream. Orbiters, landers, and international programs are building the relay, the maps, and the confidence needed for the first crew. Terraforming is still a distant idea. Mars remains a harsh world, and changing a planet is far beyond what we can do today, even with bold engineering, vast energy, and centuries of sustained effort. Mars isn't a race, it's engineering under pressure. The planet exposes every weakness and turns every solution into a blueprint for the next step. This journey doesn't just reach Mars, it changes us. What we learn there can protect life here, and open a future beyond one world. And then the real challenge begins: daily life, engineered, rationed, and repeatable. On Mars, morning isn't a feeling, it's a checklist. 2 people, 1 habitat, and 1,000 small systems that must not fail. Sleep is a controlled state, because if one system drifts overnight, you don't get a second morning. On Earth, sleep is silence. Here, it's supervised, because systems drift overnight, unnoticed. Gravity doesn't fall the same on Mars. A drop hangs longer, because water is never just water. Oxygen isn't a resource here. It's a production line, every minute, every single day. Made in silence, under pressure. And if it slips, you feel it fast. A habitat isn't shelter on Mars. It's a living machine you move through. Checking, sealing, listening. Every wall breathes. Every system whispers its status. Home here isn't a place you relax in. Home is something you constantly maintain. Outside, Mars doesn't negotiate. The air is too thin to forgive. One step beyond the wall, and there is nothing to breathe. So every breath inside is designed and protected minute by minute. Oxygen isn't found here. It's made quietly, relentlessly. Water goes in, and the habitat exhales life, sustaining fragile human presence every single day, without pause, under constant automated supervision. Mars gives almost no air, so we harvest it anyway. Machines sip the thin CO2, pulling it from the silence, and return oxygen, slowly, drop by drop. What begins as a fragile backup today becomes the foundation of a city tomorrow. Air is watched constantly. Pressure, oxygen, CO2, trace changes. Because on Mars, air isn't just survival. It's the first warning that something is wrong before systems fail completely. Water on Mars never disappears. It only changes hands. Captured, cleaned, recycled, until almost nothing is lost through pipes, filters, tanks, and habits learned quickly. From gray water to drinkable, every drop is judged. Settling, filters, UV, a final chemical polish. Yesterday's shower becomes tomorrow's drinking water, or the next meal growing under lights, measured, rationed, and monitored like oxygen itself. On Mars, water discipline is part of daily life. Showers are timed, laundry is scheduled, even condensation is collected from walls and pipes, because here, losing a single drop is not an option. Food doesn't just arrive on Mars, it's grown, under LEDs. In silent racks, every leaf is measured, every harvest is planned, because here, a fresh green bite isn't comfort, it's survival and long-term survival itself. Harvest day isn't casual here. Every cut is logged. On Mars, food isn't a meal, it's inventory. This isn't a garden, it's plumbing and math. Nutrients drip by schedule. Flow stays inside limits. One valve, one sensor, and the green survives another day. Power is life on Mars. If the lights dip, pumps slow, heaters fall behind, and the air stops moving. So every kilowatt is counted, scheduled, and protected, long before anyone plugs in a laptop. Solar keeps the colony alive until Mars turns it down. A thin film of dust can dim the light, coat the panels, and cut power quietly, right before you need it most, during storms that arrive suddenly without warning today. When the sun fades, the reactor doesn't. A compact fission unit hums through night and dust, feeding heaters, pumps, and life support with steady power. The quiet backbone that keeps the habitat alive when solar goes blind. Stepping outside isn't heroics, it's procedure. Suit pressure, radio check, leak test, tools counted twice. Because on Mars, one misstep doesn't waste time, it creates an emergency. The airlock cycle is a slow, deliberate crossing. Pressure bleeds away, fans rise, dust filters arm. Behind you, breathable air. Ahead, a world only a few millibars from vacuum. EVA is written before it begins. No wandering, no improvisation. Timed routes, counted tasks. Every step ends before the suit, for you. Outside, Mars is silent but for suit hiss and boots on dust. Low gravity, close horizon. Every step leaves a mark because a fall here is final. A normal day on Mars begins late. Messages from Earth arrive minutes behind life. Schedules are dense with checklists because routine here is something you engineer, not something you assume. Morning briefings aren't about plans, they're about survival. Power flows, air pressure, radiation levels. Outside weather decides what can live, what must wait, and what might fail today. Evenings are maintenance for the human. Exercise against low gravity, a shared meal, and a delayed call from Earth, where laughter and silence travel kilometers. Under all the protocols, you're still human. Tired mornings, coffee jokes, arguments over music. Inside sealed walls, a society begins to form, slowly, imperfectly, under constant pressure. On Mars, nothing is private for long. Decisions are shared, risks are shared, conversations stretch longer than planned, because here, every disagreement has to be worked through. On Mars, life isn't automatic. It's maintained. Every step is monitored. Every system decides if the day continues. The first year on Mars isn't exploration. It's accounting. Every system, every seal, every person, every mistake, every hour counted. Inside the airlock, everything is routine, and everything is a risk. A valve clicks, seals bite, air hisses through filters. For a few seconds, a thin door is the only thing between habitat and nothing. Regolith isn't dirt, it's sandpaper. It creeps into seals, zippers, bearings, and filter beds. On Mars, the dust doesn't attack fast. It wins slowly. In the maintenance bay, dust turns into work. Sensors are wiped grain by grain, lenses checked, seals re-greased. Mars doesn't break you loudly. It wears you down in silence. Radiation isn't loud. It doesn't warn. You only see it in the readings. So it's watched, all the time, by systems and people who never sleep nearby. Inside, the shielding works. But every EVA adds minutes under a thin sky, and the danger is just time. Water is everything on Mars. Every drop is recycled, measured, and hunted for leaks, routed through cold pipes, filters, and trays. Because loss isn't waste here, it's survival. Power is the colony's heartbeat. Out here, you don't have electricity. You maintain it, panel by panel. Skip the work, and the lights go out. Martian night is a power bill. Outside, the cold drops fast. Inside, heaters work just to keep the walls from freezing. Frost starts to creep along the window edges, like Mars is trying to take the warmth back. On Mars, breakdowns aren't drama, they're routine. Dust and cold punish every joint and motor, so survival becomes maintenance. Clearing a rover wheel before a small jam turns into a rescue. When a dust storm hits, Mars erases the horizon. Visibility collapses to nothing, and the colony switches to storm mode. Seal, wait, and hope the grit doesn't choke what keeps you alive. Earth is a lifeline, but it arrives late. Minutes of delay, occasional dropouts, a screen that freezes mid-sentence. In the comms hub, distance becomes something you can hear. Life on Mars doesn't grow by accident. It's engineered, light by light, leaf by leaf, behind sealed walls, while a dead planet presses just centimeters away. These systems are fragile. Sometimes the first warning is a single leaf changing color. In a closed habitat, failure doesn't need drama, only time and warm air. And if the greenhouse fails, you don't just lose food. You lose oxygen balance, routine, and the sense that life here is under control. Mars pressure doesn't explode, it accumulates. Small tensions settle in and start testing trust. Every EVA begins long before the airlock opens. The suit is not armor, it's a fragile, sealed ecosystem. Breathing is adjusted. Pressure is purged. One mistake here doesn't injure you. It ends the mission before it starts. Micrometeoroids never stop. Most strikes are just dust scars, until one hits something that must stay sealed. On Mars, a pinhole isn't a moment. It's a leak with a clock. Oxygen isn't found on Mars, it's manufactured. If the numbers drift, you don't panic. You fix it before the air runs out. The med bay is clean, quiet, and never off. On Mars, everything can become an emergency, while your supplies keep counting down. On Mars, we count food like medicine. Even celebrations get labeled and saved for later. Outside, it's quiet, beautiful, indifferent, like the planet never noticed we arrived. Then one warning breaks the calm. Consumption spikes. A small leak turns comfort into a decision. We stop the leak. But it costs something human. The birthday box is empty, and the habitat keeps breathing. The first year ends without triumph, just fragile continuation, one more night, and the next still coming. Did you see that?